So let's go on. So today is going to be a quick tour of traditional NLP. Why it's called traditional NLP? So the thing is nowadays we move from classical NLP to what is called uh, deep learning. A classical NLP is where we use heuristic approaches and machine learning. That's traditional NLP. But today we are not quite using in some sense. I mean, the majority, 80%, I can say for NLP, they are using kind of a deep learning approach. So as we already know, NLP is basically a branch of computer science that deals with also computer linguistics, but also there is some kind of overlap between these two scenarios. What is NLP? What is computational linguistics? So as you can see from the screen, basically NLP deals with how we can use machine learning and deep learning models actually to learn language, while computational linguistics basically deal with some aspects such as syntax, semantics, and grammatical structure. So the two things are intertwined in the sense that we can say the umbrella, for example, computational linguistics is the big umbrella, while the NLP also is a subset, but there is quite some kind of disparity between the two. And because, as we can see, the NLP also evolved from computational linguists. So before we start, we people from computer science, before we move into computational linguists, doing NLP, people from linguists, they already have what is called computational linguists, that they are trying to learn the patterns in text and some stuff like that. Then we come with more powerful algorithms, with more powerful ways to deal with, to solve some issues. And then we call our field natural language processing. So it's just like different scenario. But however, there are different stuff related to NLP. For example, we have what is called NLU. We have what is called NLG. NLU means natural language understanding. NLG means natural language generation. NLP, natural language processing. So what's the difference between the two? So if you are in the field of NLP, you will obviously hear this kind of terminology. So we need to like understand what this means. So at the high level, NLP involve all this stuff, NLU, NLG. But let's look at what is NLU. So NLU is basically natural language understanding that try to understand the semantic and meaning of a text. So for example, here we have Alice is swimming against the current. The current version of the report is in the folder. So you can see here we have the word current and we have our current here, right? And you can see the current here, Alice is swimming against the current, right? Against the current and the current version. So you can see here, the current here is different meaning. There is some kind of semantic. So the part of NLP that deals with understanding of this kind of meaning is called NLU, natural language understanding. For example, I will give you a ring. Somebody said, I will give you a ring means I will call you tomorrow, right? But somebody said the ring is in the folder, right? So you can see those two things means different meaning, right? I will give you a ring, I will give you a call. Ring here is a verb, right? But the ring is in the folder, here ring is a noun, right? So how can we model learn the meaning based on the words that close to it? For example, here we say ring, I say tomorrow. So because of a tomorrow, the model should be able to understand that ring is means to call. And because here the ring is in the folder, location somewhere folder, and mean, so the part of natural language processing that able to understand the meaning and all this stuff is called NLU. The profits increase by 10%, the pains increase by 10%. If you are doing sentiment analysis, you can say this, it's negative, right? Increase here, because the pains increase day by day, it's negative sentiment. The profit increase by 10% is positive, right? Because the profit. Now, this increase is mean it has two meanings, yeah, right? So you can see here, this is called NLU. So example of sentiment analysis is part of NLU, natural language understanding. But we also have what is called natural language generation, where computers write text, generate text. So for example, when you speak, you can see when you speak, for example, using Siri, maybe he will be writing some text, right? Yes, so you are generating text or generating speech. When you write something, Siri will say, when you write something, good morning, the Siri will speak. This is what we call natural language generation. So these are two distinct parts of NLP. Many people works with natural language understanding NLU. There are books that relates to only NLU. Many people work with natural language generation. There are some stuff that relate to only natural language generation. So this is basically as we say, the NLP is a big umbrella. For example, NLU, you can see sentiment analysis, natural language understanding, topic classification, summarizing, semantic, and this is kind of an NLP. So this is basically a quick tour on what NLP is. Yeah, anyone wants to add something based on anyone want to add something? Right. So I can proceed. Okay, now we have seen now different kind of NLP. We have NLU, we have NLG. NLU means field of NLP that understand the meaning, and NLG field of NLP that understand that generate text, and NLP is general umbrella that involves many other stuff in between. So let's move to the approaches to the NLP. So now we understand what is NLP and some different kind of subfield of NLP. Let's look at how can we do the NLP itself. So basically, for you to do NLP, there are three different ways to do NLP. One is heuristic-based NLP. Second is machine learning-based NLP. And third is deep learning-based NLP. Heuristic-based NLP basically is the olden base, not olden, but I can say also a classical that use some kind of hand created stuff. So heuristic based NLP, for example, dictionary based sentiment analysis is heuristic based, right? Because we use dictionary given a word, given a sentence, I love you, then we can use dictionary. So we will have a dictionary that contain positive word and dictionary that contain negative word. Love, like are positive, and maybe negative word, dislike, hate are negative. So when you are given a sentence, I love you, I will check in my dictionary. I see how many words that are positive in this sentence, how many words that are negative in this sentence. So if I have 10 words that are positive and 2 words that are negative, then I can conclude this sentence is positive. This is called heuristic. It's not learning algorithm. This is called rule-based. Yeah. So sometimes heuristic, we can call them rule-based, I guess, right? Or not? We can say rule-based in some ways. Rule-based. Rule-based. Yeah, we can call this guy rule-based in some sense. So there are many stuff that relates to those. Regular expression, we know regular expression. We have context-free grammar. All these are heuristic-based NLP. What the strengths of these? The strength of this rule-based is that it actually works on domain-specific knowledge. So for example, now if I'm doing sentiment analysis and I have the profits increased by 10% and the pains increased by this, if I am doing sentiment analysis and I have domain-specific knowledge, I know that this increase here will be positive. So I will make sure that wherever I see something profit and increase, then this is positive. But if I'm in medical field and some stuff like that, wherever you see pain or some stuff related to that with increase, it means negative. So in this case, increase will not always be positive, but using some kind of knowledge, domain-specific knowledge, we can infer something. We can understand it. So that's why here we say rule based on domain-specific knowledge can efficiently reduce mistakes. So for example, here you can say the pen increase because the word increase means it's positive in some sense. When you say this is positive, it means you are wrong, right? But using domain specific, you can actually do that. That is rule based. What about machine learning? Machine learning basically comes with because it's really tasking and tedious to use rule based in some sense, and it's not something that I can actually scale, right? You cannot scale rule based. Yeah, so it's really tedious and stuff like that. So machine learning comes that it learns some stuff automatically, features. Because with rule based, you are creating some features yourself, but machine learning, you can create features to learn from the future. So here we can see human create features that can be used because how can human create features? The example I gave for sentiment analysis is somebody can sit down to create lexicon, dictionary. What are the positive words? You search one file. What are the negative words? Put them in one file. And now when you have a new text you want to classify, then you find how many positive words you have. So you can see this is human that does that, that define the features that categorize what is positive or negative. But we have machine learning based that actually create the features automatically for us. So this means that you don't need to use human to create your features like dictionary. Or no, machine learning, that is what is called machine. It is machine that learn. This heuristic we can say human learning. I don't know. So some of the common algorithms that can be used for machine learning are naive-based, logistic, support vector, hidden Markov shell, conditional random forest. For NLP, these are some of the common algorithms that are being used for NLP. And you can see here some of the steps to use for machine learning to do NLP is extracting features from text. So you can see here who extract features in machine. In this example I gave, is human that sit down and create a dictionary for positive and negative, right? And create that dictionary. And when he has a new text, he will find how many positive words we have, how many negative. But here, the machine learning algorithm will extract the features from text automatically for you. So you can see this is extraction feature. So here we have, you can see here, we can see disadvantage. For example, we have manual creation of features, manual curation of features that can allows you to do some stuff, right? But here, yeah, but here we can see that the algorithm will automatically, you can extract feature using the feature to, you can give the model these features, and finally you can balance. So this is machine learning based. But curating these features also, in some ways, in machine learning we create the features ourselves. It's not like the machine learning that curate these features. It's not the algorithm that we also help the algorithm to create the features, right? Like this one. We help the algorithm to create the features. It's not like the algorithm that creating the features, but the algorithm extract these features to fit in the model. But that's also time consuming and in some sense, non scalable. Deep learning comes. So deep learning, when it comes, it eliminates all the issue of creating the features from yourself. It automatically creates features. For deep learning, for NLP, we use many approaches. Convolutional neural network. I think Dr. Amina is her presentation, her PhD, this is what she did for us. See convolutional neural network, sequence models, recurrent RNN, LSTM. So these are some of the sequence models that can be used for NLP. However, convolutional neural network was basically from inception were used to learn images for image recognition and some stuff like that. But now it has been used in NLP field, machine translation, sentiment analysis. This is CNN. We have sequence model. Sequence model basically are kind of models that actually learn that this text is a sequence from 1 to n, and it learns some kind of features as the text progress. But there are some issue with this, as we will see in the next features. Here I'm just going through the method. In the next class we will see some of the issue with RNN and LCM. But for deep learning, the method that we use for NLP, number one, we have convolutional neural network, we have sequence model, and we have the next one is what is called transfer learning. So transfer learning is basically a way in NLP where it also emanates from image field guys that are using image. What do you call it? Not NLP. What is the field that are dealing with image in?
Computer vision.
Yeah, computer vision. So transfer learning also emanates from computer vision, but it now used, in fact, in NLP. So basically, what means transfer learning? So let's assume that I use, I have quite number of texts for that I can use sentiment analysis in English now, so I can develop a good model to work in English. But I don't have enough data to work on Hausa. So I can do what is called transfer learning. I can just use that model that works in English with some kind of modification now to use on small data in Hausa. That is, you transfer some stuff. So there is a lot of stuff that deals with this approach where you transfer some knowledge from one model that you train, different from your domain, to another model, and it works quite well. Interestingly, this is an area called transfer learning. In fact, there is a book dedicated called Transfer Learning in NLP, or transfer learning for NLP. And we'll see this transfer learning in the next couple of chapters. But just trying to recap, deep learning for NLP, we use CNN, sequence model, transfer learning, but now we use what is called transformers. Now, what is transformers? So transformers are now the state-of-the-art NLP approach. If you want to do NLP, this is where you will come, transformers. It models. So one of the problem with sequence model is that, for example, if you have a long text, when a model learn, what I mean by long text is that, for example, I have a sentence that contains of 50 words, 20 words. So if a model learns the first 3 words, the relationship, the model may not understand the last 3 words because it's 20, right? So this is the model have neural capable of remembering what is proceeded so far. Sequence model can learn what is proceeded, maybe 3, 4, something close to it, but it cannot learn the entire text to make meaningful some stuff. Now, transformers solve that issue. It models the textual context in non-sequential manner. So sequence model, the model that our stuff in sequential manner, this model, given a word in the input, the model looks at all the words around it and it represents each word with respect to its context. This is referred to as self-attention. So in NLP, this is something in NLP, self-attention whatsoever that will come to do that. But to recap, transformers are the state of the art, and this is where we are going now when we finish this book, transformers, the book we have, transformer for NLP. This is where we are going. But yeah, so this is basically a recap of NLP approaches, heuristic-based approach, machine learning, and deep learning-based approach. Yeah, anyone want to add something before we move? Anyone want to add something?
Yes, with regards to recurrent neural networks, so the idea with attention mechanisms was introduced, I think, in 2015 by Luang et al. So what they did was to understand this problem of not getting to utilize all of the whole sentence, and they brought about the attention mechanism, and it was developed further by Baden also, I think, in 2016, 15, and then to 2016. So what Transformers did was to like revolutionize the use of self-attention. So they remove all other features. They rely only on this self-attention to create the Transformers, and it's just like era defining in terms of NLP. Yeah.
Yeah, thank you. Anybody want to add something? Yeah, so in chapter 8, we have transformers and this attention. In chapter 8, we'll see the details about what attention is in transformer in chapter 8. Yeah, right. So anyone want to add something? Okay, so now we have seen 2 things. We have seen what is NLP and what are some of the subset of NLP, and now we have seen how can we see NLP. Now let's look at doing the NLP. So doing the NLP, you basically need the stuff, corpora or tokens, or data set to do that, right? So what we mean for NLP, there is some kind of stuff that works. There is something called corpus. There is something called data set. These 2 things are used interchangeably, but when we say corpus, for example, is something that represent the general power. So, for example, when I crawl tweets in its entirety, I have bunch of tweets. Maybe I have 50,000 tweets. Then I can say I have a corpus, right? I have a corpus. But when I annotate that corpus for sentiment analysis, and I give each tweet positive, negative, each tweet positive, negative, neutral, then that transformation is called data set. So you can see a data set is a representative sample of specific linguistic phenomena in a restricted context and with annotation that relate to specific research questions. That is called data set. But corpus is a general some sense. So you can see here I have corpus. After you do some stuff, you can have a data set. So for example, here you can see this is general corpus here. And now here you can see this is a text. You can attach some metadata. This is positive, negative, positive, negative. And now for each one is called instance, as we know in machine learning. So when you have these this stuff with annotation with instance is called data. So, but just to make sure that we know how to distinguish between the approaches, a corpus is general sense, and data set is when you have something specific. Right. So let's look at the general pipeline for the NLP. There are many variations. This is not hard and fast, but let's look at it. So now we have seen this. The first thing for anything we want to do for NLP is to do data collection, test cleaning, pre-processing, feature engineering, modeling, evaluation, and stuff. So this is some of the steps. And so let's look at some of the steps involved in NLP that relate to these processes. And by no means we'll exhaust them, but we just, so let's look at the first one, data collection. So data collection, how can you do data collection? So if I want to do sentiment analysis for tweet, now the first thing I need to do is to go, for example, if I'm going to use for Hausa language, which I don't have, for example, data set, is to crawl tweet, right? To crawl tweet from the beginning. If I crawl tweet, now I need to get annotators, give them this tweet, and now pay them to do the annotation. For example, give them some money, and now you need to have annotation tool online to annotate the data. Now, this is something ideal setting is we have everything needed. So for example, now if somebody want to do sentiment analysis in Hausa, he does not need to go all this process or download into it. For example, we have the data set, he can use our own, right? So that is ideal setting. So you need to have the data set with levels annotation. But very often we deal with non-ideal situation. So in non-ideal scenario, for example, when we're trying to do sentiment analysis, that is non-ideal. We don't have data set for sentiment analysis in Hausa, so we have to need to scrub the data, or if you have, you need to look at right. So that is it. So initial data set with annotated level. So, but sometimes you have your data set, but it is only few. For example, you want to do sentiment analysis in Hausa, and you only have data set which is like 500, 1000, and you feel like, oh no, I want to train a big model with large amount of data. Now there is a solution. If you have limited amount of data, that's what is called data augmentation. So data augmentation is basically a way to exploit the existing properties of your data set to create something similar to that. So for example, I have data set which is like 1000 for sentiment analysis in Hausa, and I have tweet like 5,000 or something like that, So I can use data augmentation, or you can even create synthetic data. So what is data augmentation? One way to create the data augmentation is like synonym replacement. So for example, I love this house. Then if you want to create more data set, then what is the synonym of love? A turanci me synonym of love. Tofa. Love. Now koma secondary. Me synonym of love.
Ado.
So if you say I admire this work, so you see you create a new sentence, right? Which is
Yes.
so this is called data augmentation. Creating the more data. Related word replacement. Back translation, replacing entities. For example, like replacing entities, adding noise data, adding random stuff. So this is basically a very big field. There are a lot of papers related to that, but in essence, data augmentation is basically exploit language properties to create tests that syntactically similar. So the basic one is synonym replacement again. There's also back translation. Yes, it is. Tell us about back translation. Okay, Idris is not around, right? Okay. The reason why I say Idris is like he wrote a paper because his PhD is machine translation, and he wrote a paper on back translation. That is his PhD, back translation. So if Idris, you are around.
Yes, Dr. Gani.
Okay, so we are talking about data augmentation. I give an example, one synonym replacement, and there is data back translation. I say your PhD is back translation. Tell us a bit about back translation.
Yeah, so the idea of back translation is using a model. So usually we rely on human annotated data to do tasks, especially machine translation that require a lot of data. So in a situation where the data that you have is very small, so you can use that data to train a model and use the model to generate a larger amount of data set and use that data, which we call synthetic data, versus authentic data, which is generated by a human being, to train a more qualitative model. And research has shown, so back translation is like synonymous to self-learning, in which so the difference between these two is just the direction in which you are translating. In back translation, if I will give you an example with, let's say, English to Hausa, So you will train a model that will do translation between English to Hausa, and then the final model that you are training will be a model for translating Hausa to English, so reversing it. But in self-learning, you do the same process, but you are trained the same direction. So the model that will generate the data is English to Hausa, and the final model also is English to Hausa. So you are just using a model that is trained on the small amount of data that you have to translate a very larger amount of data that is not like parallel between the languages. And then you mix in these two data and you create another model. And that model, like research has shown, its performance and accuracy is much more better than just using the smaller data that you have. Yeah.
Right. Thank you, Dr. Idris. So, in a nutshell, we have seen the first one, NLP pipelining, data collection. One, how can you do that? Create your data set, do annotation. If you don't have one, if you have existing one, use existing one maybe from Kaggle, from wherever, download existing one. If you don't have the existing one or you have small one, you can do data augmentation. Then the next one is test cleaning. Yeah, so in test cleaning, what we mean by test cleaning is that so for data cleaning, data collection, if we have time, one day we can organize. I can walk through us for people that are interested for like collection of tweet, how one can collect tweet and do some stuff. Yeah, for example, we talk about with Saminu, people that are working on Twitter. We can have a session that I can go through collecting of tweet data and do some kind of processing. Yeah, so we can discuss that. Now, the next one is data cleaning or test cleaning. So this is basic NLP that we are working. We'll see a lot of all this in the next couple of chapters. So what is data cleaning? So data cleaning is basically just removing some stuff from your data. So for example here, removing not textual information. For example, here you have emoji and stuff like that, and you are working on sentiment analysis and you don't want to this one. So you can basically remove them. So here you can see we have this, but you can remove them. Here is like using Unicode. This package, you can see I remove all this stuff. So this kind of stuff is what we call data cleaning. So sometimes, and data cleaning is depends on the task you are doing. Each and every task you are working on NLP has involved its own data cleaning stuff or whatsoever. So this is just what we mean by that. The next one is pre-processing. So now we have our text clean. So we need to pre-process this text and put it in some shape that actually we can do NLP with it. That is what is called pre-processing. Now, the first thing in pre-processing in NLP is what is called sentence segmentation or word tokenization. So when you have raw text, what you need to do first, what is done first is tokenization. Tokenization is basically given a sentence, this is a sentence, tokenize it, natural language processing, tokenize it to get each word from sentence. That is called sentence. So we have many tags, for example, tokenization, text cleaning, part of system again, stop word removal, lemmatization, stuff, a lot of other stuff. So one thing that we do first, given a text, is to do tokenization. Yeah, tokenizers. So we call this stuff called tokenizers. And yeah, in sentiment analysis, I gave an example. For example, given a text like this, I really love this, but not in the beginning, you can tokenize this and now try to find what is more, how many really love. You can see I really love, but not, you have not one, and you can see how much. So this is basically some kind of stuff. Yeah, of course, there are many tools you can do this kind of tokenization. One thing is that you can use NLTK, but there are Spacey, there Spacey, there are NLTK, there are Gensim, all this stuff. All these stuff packages that allow us to do a lot of other stuff. So here, for example, I import sentence tokenizer and word tokenizer, and now given this sentence, I want to tokenize it. You can see I tokenize this stuff. You can see here we have Python. You can see is and interpreted. So this is what we call sentence tokenization, tokenization, which is one of the tags in NLP. Yeah, but there are some issues with tokenization for agglutinative language, such as Turkish, is it Turkish? Yeah, Turkish. So agglutinative language is difficult to separate words. So here we can see it's just a normal English. We can separate this, we can separate this, we can. But some agglutinative language, this is how they are. Haka suke agglutinative language. Haka yake kuma aka suke gane shi. Haka wai yana nufin sentence ne haka. This is agglutinative language. So kamar Turkish haka suke. So it's difficult to work with agglutinative sentences or whatsoever it's called. But we'll see. Deep learning, in deep learning, some stuff it basically removes this kind of step in some sense. So, but apart from tokenizing that we do first, there are some frequent pre-processing steps that are involved. Stop word removal, meaning we all know stop word. For example, if I'm given a text like this, oh no, if I given like this is a good film, we love it. So in some sense, for example, I'm just giving sentiment analysis because that is what I know most. So stop word removal, stop word are words that occur many times in sentences in language, but they don't have kind of meaning, they don't contribute some stuff. So for example, is a stop word, it is a stop word, this is a stop word. So now I can remove this stuff and I can try to find the sentiment of this. I think it's also stop word. So now I have three words. I can find the sentiment of this, good and love. I can say this sentence is positive. Why do I remove these words, this stop word? One reason for removing this stop word is that those days, computational power. If I have text with this, how many words do I have? 1, 2, 3, 4, 5, 6. The time it will take and the resources it will take to do computation on this will be minimal with the time it will take to do computation on 3 words, right? So one of the things I think in olden days, one of the main reason for removal of stop word, if I think maybe one can tell us again, was just the time it takes to do this kind of processing. But also removal of stop word is task dependent. Some tasks don't need to remove that, but in sentiment analysis, in some way we do that. Especially for classical machine learning, but in deep learning, we don't remove stop word. In some sense, we just give the model the text and the model can learn everything from the text. So that's this. So yeah, so that's stop word removal, and that's what we call stemming and lemmatization. That is digit and function. So for example, I love this field is featured first, something like that. So if you have text with numbers and punctuation, we also remove punctuation for doing sentiment analysis in some ways sometimes. So this is also part of pre-processing. So you can do all this with packet, for example, NLTK here. For example, I have this is a text sentence. Now I can use NLTK, download the NLTK stuff, and now I can use remove that. And you can see here I have Mr. John Onel works. So you can see here I already removed this what do you call it, this comma, can you see that? And I remove word number, can you see that? Because I said for if w not in this, not in punctuation, not in digit, and we remove return the D. So here we remove all the functions. So this is one step that we use in classical NLP, that is removal of digit, punctuation, and stop word. And in some ways, there are a lot of literature that said removing this kind of stop word, punctuation, and digit increase performance of NLP tasks, such as sentiment analysis or some stuff. But yeah, there are a lot of literature. So in some ways, you need to practice with different approaches, remove this stuff, and run your model, see how what works, and fine tune it, and do whatever you like, and do that. Right? Anyone want to add something regarding that? Okay, so another kind of pre-processing step that we do for NLP is stemming and lemmatization and case normalization. Oh, there is something called case normalization. We can normalize this. You can see this is capital, because why do we need to do case normalization? For example, if you are doing looking at a review, somebody can say this is this is good movie, and somebody can say this is good movie. Now, if you train your machine learning model will take this good different and this one different. So for you to make sure that your machine learning model understand good is the same as good, what you need to do is just to on case normalize the case. If it normalize all everything to normal lower case ake cewa ko to lower case, ka canja komai, kai turancin ya fitowa, ka canja komai zuwa lower case. So you can see in that case you will not machine learning model can understand everything. So that's what they call case normalization as well. So this is also part of pre-processing of your text to make sure that everything is the same in some sense. There's the next one that we see here in this step is stemming and limitations.
Dr. Shamsu.
Yes, sir.
Now, yanzu aka zo magana case normalization sunan to ai za a samu kaman problem idan kuma mutum zai yi name entity recognition ne a approach dinsa.
Yeah, shine nace ai wa'annan tasks din they are task dependent. So yeah, they are task dependent. So in some tasks you don't need to do yeah, this is not necessary steps. So it depends on the task you are doing. If we are doing sentiment analysis, as I gave an example, if you have this is good and the good is in small letter and this is good, the good is in capital letter, you are not helping the system. You need to normalize them, right? Because good in capital letter will be different. If you have good for the movie, if I'm doing I'm trying to find the whole review for people. Let me give an example. This is good movie. This is good movie. This is bad movie. So if I want to find review that people review a particular movie, now I have this. Now when I want to do sentiment analysis, right? I want to do sentiment analysis. Though this one will be positive, this one will be positive. This one will be negative, but we want to make sure that this good and this good, especially when you are using lexicon-based sentiment analysis. So if you are using lexicon where you have a dictionary, in your dictionary you have everything lowercase letter in dictionary, lowercase, then the good in dictionary will not be able to capture this good. Kagani this one will be neutral. If you are using lexicon-based, this will be neutral. Because the dictionary, this will be negative, and this will be positive. For example, if you are using lexicon-based sentence, because in lexicon-based, you have a dictionary where everything word, positive word and negative word are there. And in our dictionary, we all our word in small letter. So you can see here, I say because I'm confused. To I mutin daya ya ce positive, wani ya ce neutral, wani ya ce negative, to wanne ne daidai. Amma idan muka made da wannan small letter, za ta koma haka. Good. So means kenan wannan positive. To yanzu za mu ce mutane biyu ai sun ce wannan movie din is positive, mutum daya ya ce negative ne. To kun ga za mu ga cewa lalle zan ga movie din nan. Wannan movie din yana da kyau tunda har mutum biyu sun ce is positive. I don't know if this makes sense and it's helpful. So the short answer is that these tasks are task dependent. It depends on the task you are doing. For example, yeah. So don't take this one as something that is universally true for all the tasks.
Yes, I think one thing to add is, as Dr. Shamsu said, it's not even only on either lemmatization or stemming or case normalization or let's say stopwatch removal. Even in tokenization, it's also task dependent because there are different types of tokenization. So now I think it's easier for us to understand if we narrow it to an example. But in the example, usually, as the Shamsu is doing, there's a caveat, meaning that this is dependent on sentiment analysis. But there are other tasks that require different sets of rules and the rest. But majority of them are just similar. So just maybe in one task, you will not find this set of pre-processing. In other tasks, you will not find different sets of pre-processing and the rest. Yeah. Doctor, you are mute.
Okay, sorry. And the next step in terms of pre-processing, we are still in processing step, is stemming. So stemming, basically, you can see this just a single word, right? So stemming is a crude way. Basically, it's a poor man's what is they call lemmatized that they cut. For example, idan ka gana anan ai E din nan duk cutting E misali na an cutting E na an cutting ing na an cutting es na an cutting ed na an cutting er. So we in some ways wannan ana cutting din abu ne ya baka wani abu. This is called something like that stem, right? But there is something called lemmatization. Shi kuma lemmatization is more intelligent, zai baka root word din abin nan din ne. So here we have wannan kuma ana ce mashi ina ji stem. So this will give you the stem. This will give you something like that. So in some ways, I mean, lemmatization is widely more used than stemming. So why do we need to use this? So if I'm using sentiment analysis, as always give sentiment analysis, if I'm using sentiment analysis, oh my god, one example zan kawo na statement da zai dauke
ku. Loft da wai.
Na, ne kace?
Loft.
Yawa, loves, loving. Yawa. So kaga idan kana yin sentiment analysis, then you want to mix all these loves to a single word. You need to change them to only love, so that zaka abin nan. Ka ji wannan gayan. Wai ce ma ka kama wannan. So this is some kind of step that we need to use in sentiment analysis in NLP. So we all know this is called lemma. This is called root word. I think if I don't forget, we have the English here. Lemmas are the root form of the word. Consider the verb fly. It can be inflected in many forms. So these are some of the inflection of the word fly, flee, flown, and so on. And fly is the lemma. So this fly is the lemma for all of this single. So sometimes we need to change the lemma. So we have what we call stemming algorithm, and we have what is called lemmatization algorithm. So sometimes it might be useful to reduce the token to their lemmas to keep the dimensionality of the vector representation low. So why do we need to use this? One idea is this, as I give an example of low, but look at this. I have changing. Now, if each word za a bata haka, then if you come to do machine learning, you can see that you will have large number of the vector. Your vector will be large. It contains many features. So here is some way of also changing the dimension, keeping the dimensionality of the vector very low. Like instead for you to have the vector with for this 7 representation, you have only one word. So this is one step that also in use. So for also stemming, given for example cars, revolution, beta, using NLTK, we have Porter stemma, which is stemming algorithm. I imported and create the object stemma, and now here I have words. Now I can use this stem. So when we run this, you can see here from cars, it gives me this, right? So this is stem. At the same time, I can use lemmatizer from WordNet, and also using NLTK WordNet lemmatizer. So here you can see because lemmatizer, as you can see here, popular stemmers. Stemming is a poor man's lemmatization. It involves the use of hand-crafted rules to strip ending of words. So this it involves some rules. It is based on rule that you do stemming here. It's not like some learning. So, but lemmatization, because it requires some kind of linguistic stuff to remove something. For example, you need to say something is noun or verb or some whatsoever. It do that. So you need to give a part of speech tagging. So here we give part of again noun, and adjective and stuff like that. Now we can see here, you can see here revolution. It just cut it here, the stemming, right? But we have for lemmatizer, it gives us revolution, right? Because we know that this is noun, this is noun, this, so this is adjective. So there is some details about that, but in a nutshell, what we mean by that is that stemming and lemmatization are some ways to give us the lemma in some sense. So important reminder, not all steps are necessary. These steps are not sequential. These steps are task dependent. But the main goal for pre-processing is we need to normalize, tokenize, and do some kind of enrichment. So that's about, we have more minutes. Oh, we have 10 more minutes. Okay, this is tokenization. You can also use Spacey tokenizer to do tokenization. For example, here is using Spacey to tokenize. We also have feature engineering. Okay, what step do we have next? Okay, feature engineering. So after you pre-process, then you do feature engineering. So feature engineering, a process to feed the expected and processed set into machine learning algorithm. Now, given our pre-processed text, how can we extract some good features that can feed into machine learning algorithm? So there are some good way to do that. For classical machine learning algorithm, we have different ways: word-based, word-based, bug up, word domain-specific, word frequency, handcrafted, feature-based, domain-specific knowledge. So these are some of the future engineering, and we'll see them in the next session. But let's go a little bit on some representation. For example, bug of word. I think do I have part of, let's see. So there is something also the book discussed: unigram, bigram. So, for example, what we mean by bigram, unigram, n-gram is that sometimes we need to generate our text into some kind of representation. So here, when we have a text here, I have Jack, I have a text. Now I have a bigram, 1 gram representation, 2 grams. So here, 1 gram, that is one word, one word, one word, one word. Bigram, that is, you can see Jack is very, very good. I can have 3 gram. You can see this is the representation I have. So what is the meaning of this? Sometimes if you want to do NLP, for example, still sentiment analysis, you need to change your words. Sometimes you need to create whether n-gram you want to use n-gram as your features, where you want to use bigram. So if we use unigram, for example, Jack, we give our machine learning model, Jack is very to learn from these features. But if we give him like a 2 gram bigram, so we can see he can learn from this. But you can also have a mix of bigram and n-gram. So also this, there is a lot of studies that shows which one is better, whether 1 gram or n-gram. So this in a nutshell is that when you want to do machine learning, given a sequence of text, because you remember in the previous step, we use what is called text normalization, and we use tokenization, meaning in previous step, we tokenize our word, we tokenize our text, right? Giving them into one. So if you have 1 million text, you will have something like this. So the next step that I'm showing is the future engineering, which is called putting your text into whether unigram or bigram, and it depends on the task. You can use bigram or unigram. But we also have PyTorch switch tagging. So PyTorch switch tagging is also one of the tasks for NLP, which is the future. Either it attaches the also you can do that with NLTK. It gives each word the part of speech it belongs to. For example, here we have easy GG here. What is this? NN, you know, I don't even remember the Bob. I think this is Bob. What is NN? Can somebody help us? An NN or adjective or something like that. So we all know part of speech tagging, part of speech. So part of speech tagging means tagging each word with its own representative from part of speech. So this is one of the tasks also that involved in classical NLP and in general NLP. But for future engineering, for deep learning, so we don't actually create features for homage. So in machine learning, we create features such as bigram or n-gram, or we can use embedding as our features. But here we are talking, I think, classical NLP. Remember this chapter, so it's not about embedding. In the next chapter, we will see that. This chapter is basically laying us foundation, telling us what is done. So in deep learning, we don't actually have create the features. The deep learning algorithm automatically learn the features itself. Yeah, so the price is the model is often less interpretable. So because here we create the features, in some way we help the algorithm to learn the features manually, but deep learning, you don't create the features, you just give it. And but the disadvantage is that the model is less interpretable. You don't know what is happening because the model is the one that just kaba machine shi abu daga kansa ya maka komai ya da maka da shi. So this means that it's less interpretable, meaning it's less explainable. You may not know what is happening. But for machine learning, where you have your features, you create a feature good, bad, kaza da kaza ka ba, so ka san features ɗinka, amma nan babu. Finally, we have, finally, modeling. So we can see here, we have modeling. So modeling, what it means, now you create your features, and now you need to model with machine learning algorithms. So how can you do? Now you create features. You start with heuristic. Maybe you want to do sentiment analysis. You can start with the lexicon-based, heuristic-based approach. And and also you can scale. You can use machine learning algorithm, as we'll see. Most importantly, you can use ensemble and stacking. You can do transfer and many approaches, as you will see. So always, when you want to do the modeling as well, start with simple to complex. What we mean by simple is that let's assume I want to do machine learning for sentiment analysis. Now, what you need to do is start with dummy classifier. In scikit-learn, there is what is called dummy classifier. So start with something that will give you the baseline of your experiment. So dummy classifier, for example, for sentiment analysis, are the one that basically classify the text into some kind of frequency. They are called dummy class. I will see example. So make sure, like, when you want to do modeling, start with simple, such as dummy classifier. Then you can now build on top of that to build some powerful algorithm that can beat that dummy classifier. So always, when you want to do modeling, try to build a baseline. And now your aim is to beat that baseline. So when you build the baseline, now you select more powerful algorithm that will beat the baseline. Yeah, so that is basically the introduction of this chapter, a quick tour of traditional NLP. Any